Hey folks, this is Rahul, and let me quickly share my screen. All right, is my screen visible to all?
Yes, Rahul, we can see.
All right, all right. So in this module, we'll continue exploring the app services, and in this module, we'll explore around scaling configurations. We'll explore around monitoring metrics. Then we'll explore around web jobs, called as the silent warriors, and then we'll see some assorted trades for the app services. So let's start by looking at the scaling configurations. So let's start with scaling. Let's understand first of all the intent behind scaling. So any enterprise applications that we have sees an unpredictable traffic trend. There may be times when you see a heavy load on your website, and there may be times when you see a very less traffic. So because of the nature of the traffic, you would want to scale at times when you see a heavy traffic. And Azure App Services gives us an options to scale vertically as well as horizontally. So let's understand what does it means when we say vertical and horizontal scaling with the help of an example. So on the right side of the slide, we have a picture displayed with a bus, and bus is having a single capacity, a single story. Now, if I add some additional capacity to this bus, if I add another section to this bus, then it's all about vertically scaling, which means that I'm adding some additional capacity to my current capacity. So this is all about doing vertical scaling. So when it comes to your infrastructure, what exactly vertical scaling means? Vertical scaling means that you are adding more power to your server. So say your server is a 4-core 16 GBs machine, and you are scaling it up to 8 cores 24 GBs. There it means that you are vertically scaling up. And if you are scaling it down, which means from a 8 core 24 GBs machine, you are scaling it down back again to 4 cores 8 GBs machine. So that's only about adding additional capacity to your current capacity. What does horizontal scaling means? Horizontal scaling means when you are adding more instances, but similar type of instances, you are adding more. So here we are having a bus, but we have added another bus, which means having similar capacity, but there are now two buses. So in terms of your infrastructure, what does horizontal scaling means? Horizontal scaling means that you have added another instance of your app service. So currently, if your app service is running with one instance, and if you scale it to two, which means that you are horizontally scaled that app service. So let's quickly see on the portal how can we scale up and how can we scale out. So I am on my let me close this. Let me go to the overview tab. So I am on my app service. I'll quickly search for scale. I'll get two options. One is scale up and one is scale out. Scale up is all around vertically scaling your system, wherein we are adding additional capacity to our current servers. And scale out is all about horizontally scaling, wherein we are adding additional instances. So first of all, let's look around scale up. All right. So this shows different plans that we are having on top of Azure. So currently I'm using a 1-core machine. I'm on S1 plan, wherein I'm having a 1-core machine with 1.7 gigs of memory. I can scale it up to say two virtual cores with eight gigs of memory. I can go to this plan, which means that I've scaled up. I can also scale down. So if I move to a shared plan or a D1 plan, wherein I'm using a shared infrastructure which is having 1 gigs of memory and some shared cores. So both these in both these scenarios, what I am doing, I'm either adding additional capacity to my current instance or I'm removing those additional capacity. So this has a direct implication on your cost. If you are moving to a higher plan, as Surpi told in the first session, you have to pay according to that plan, and if you are moving to a lower plan, then you have to pay according to that plan. So say if I'm moving to this plan, I'll be paying around 627 INRs per month. But say if I'm moving to this plan, then I'm paying somewhere around 5k INRs per month. So this is all around vertically scaling. Let's quickly see what does scaling out means. So Now, scaling out, I am on the configure tab of scaling out. This is when we are doing horizontal scaling. So there are two options available. One is manual scale and one is custom scale. Let's quickly see first what manual scale is. So manual scale gives you an option to manually bump up the number of instances. So currently I am on 1, and I can manually change this value to 5. So there's now 5, and the moment I'll say save, what Azure will do, Azure will spin up 5 instances behind the scenes, will do the deployments, and will start distributing the traffic using load balancer. So it's all abstracted from us. Using a single click, which is save, we are spinning up 5 instances, and automatically Azure is taking care of all the deployments and distributing the traffic using a load balancer. This is all around manual scaling, and some very practical use cases of manual scale is maybe you are seeing a very heavy spike of traffic, and that's an unexpected spike, and you would want to scale there and then, and it's an unexpected spike. So that's why you come to this option, you come to the configure tab, and you bump up the number of instances. But when we see in any enterprise application, we do not want to go ahead with a fixed infrastructure, going ahead with five instances. I do not want to go with 5 instances because that will incur me a fixed cost. And maybe we are not leveraging the benefits of cloud. Cloud is offering us elasticity, which means that we can scale up, scale down, scale out, scale in. So we would want to leverage the elasticity feature, wherein we would want to auto scale based on some metrics. So let's quickly see what exactly auto scale, how can we configure auto scale. So when I go to custom auto scale, I see that I can add some conditions. I can scale up based on a metric. Metric can be CPU percentage, memory percentage, HTTP request, or I can scale up on specific days. So let's first cover how can I scale based on a metric. So I can add a condition. I have selected scale based on a metric. Let's quickly add a rule. So I'm on my app service plan, which is Azure Geek. This is my current resource. If I go down, I'll see two options. One is operator and one is metric. So, okay, let me go up. Yeah. So first of all, let's see what metrics are available through which you can scale up, scale down, or scale up. So I have multiple metrics available, which is CPU percentage, disk queue length, HTTP queue, memory percentage. So let's see how can we scale out using CPU percentage. So here I've selected CPU percentage, and now I'm going to define the criteria. So when my CPU percentage is greater than 70% for a continuous duration of 10 minutes, then what action I want Azure to take is increase the number of instances by 1, and eventually having a cooldown period of 5 minutes. Now, what does this cooldown period means? That after scaling up, after evaluating this rule and scaling up by 1 instance, Azure will wait for 5 minutes to get the system stabilized. During those 5 minutes, even if the CPU is greater than 70%, Azure will not evaluate that rule and will wait for the system to stabilize. After 5 minutes, once that system is stabilized, Azure will again evaluate the same rule, that the CPU percentage is still greater than 70. And if it finds that the CPU percentage is greater than 70, it will again increase the count by 1. And again, eventually having a cooldown period of 5 minutes. So this is how I define my scale out conditions based on a particular metric. You can define based on other metrics also, like memory percentage, HTTP request. These are some of the metrics that we use on our enterprise application. So if I quickly add this, okay, this one's already added. Now, since I've added a rule to scale out, I also need to add a rule to scale in, because I do not want my system to always run on that fixed number of instances once it scales up. So let's quickly add a rule for scaling in. Again, I'll add a rule based on CPU percentage. So I've selected CPU percentage here. I'll go down, and this time I'll select less than. I'll change this value and I'll change it to 30. And I'll say, instead of increasing count, I'll say decrease count by. So what does this mean? That Azure will start evaluating this rule and say, when the CPU percentage of my app service is less than 30% for all the instances, average CPU, then decrease the count by 1, eventually having a cooldown period of 5 minutes. The cooldown period again here signifies the same thing. So this is how I add a scale in rule. So here is scale out and scale in. So this is all around scaling based on a metric, but you can also scale based on particular time of a day. Let's see how can we do that. So here I am. I can scale to a specific instance. I can scale to say I can say five instances, and I can specify the time of the day when I would want to scale. So this type of use case is more valid. Say you are having an e-com application, and there is a sale on top of your website, and you are expecting a lot of traffic during that particular time. So you can say that during all those days when the sale is open, then the system will be running with 5 instances or 4 instances. That's again the feature of Azure App Services, using which you can scale, and you can define the days when you would want to scale, and the moment the days will be over, it will automatically come back to the default condition which we have defined here at the top. So these are two ways: scaling based on a metric and scaling based on particular time of a day. This is all around what we wanted to cover for scaling. Let's quickly go back to the slides. All right, this was what we went through. We went through that how can we bump up the instances manually, and how can we add an auto scale rule. Auto scale rule can be added based on schedule or metrics. Now, a tip uh, for everyone based on our practical experience. Azure charges based on the hour of the day. So in case, say, if during the start of the hour the number of instances are 4, and after the start of the hour you reduce the number of instances to 3 or 2, but still you will be charged for 4 instances. So that's a word of caution, and that's what we also got to know from our practical experience. The other tips are, yes, for peak non-peak traffic, always leverage the auto scale rule. All right, moving forward, this we already saw. Moving forward, let's see monitoring. So any enterprise application, it's not just deployments and development of that application. There is also a very important aspect, which is observability. Now, when it comes to observability, there are three important aspects of observability. It's logging, tracing, and monitoring. Now, what we are discussing here is one of the key aspects, which is monitoring. So let's see how exactly we can monitor the health of an app service in Azure. Azure offers lots of metrics which are out of the box to find the health of your application, to find the health of your app service. They are HTTP. So there are three kinds of metrics that are available, which is HTTP request metrics. You can find out how many HTTP requests your app service is currently serving. You can find out how many requests are currently there in HTTP queue. You can find out response time and some other information. Plus, Azure also exposes a lot of metrics which are low level metrics about your app service, like CPU percentage, like memory percentage, or disk queue length. All those type of metrics are also available out of the box in Azure, and you can use them to find the health of your application. Worker process, for a specific IIS application. If you're running a .NET application, you would want to understand the number of garbage collections that have taken, generation 0, generation 1, generation 2, number of connections that have been made to your application. All this stuff is available out of the box on top of your app service. Let's quickly see some of these metrics on the Azure portal. All right. All right, I'm on the overview tab, and once you on this overview tab, if you scroll down, there will be some panels available, like this HTTP 5xx, data in, data out, request, response time. This will give you a general health of your application. You will be able to identify the general health of your app service, like how many HTTP 5xx errors are there, what is the data in, what is the data out, how many requests are being served by your application. So as we can see, it's somewhere around 30 requests per minute. And what's the response time? So it's less than 5 seconds currently. So All these panels are pinnable. In case if you are panel, this panel will be available on top of your dashboard. So Azure has an out of the box dashboard that will be available right there on top of your dashboard. So whenever you will open portal.azure.com, you will be able to see all these panels. Again, all these panels are clickable. If you click on these panels, that will open a separate window, and you'll be able to select the time duration for which you would want to see this stat. You would want to see this metric. So you can see last 4 hours, last 12 hours, last 30 days, or any custom metrics. You can decide for which 2 days you want to see all these metrics, and you will be able to see that. Again, there are multiple metrics available. As I said, on top of your app service, you'll be able to see CPU time, data in, data out, all these generation zero collections, generation one, handle count. All this you'll be able to see from here. This we are looking the metrics that are available on top of your app service. Now let's quickly see what all are available on top of app service plan. So as we covered in session one, app service plan is the first thing that we create, and out of that we create our app services. So on top of your app service plan, you will get to see again on the overview tab, you'll be able to see all these panels, which will give you the CPU percentage of your apps, memory percentage, data in, data out. Let's click on CPU percentage. Now this is showing the CPU percentage of your average CPU percentage across all the instances. So if supposedly if you have scaled out and you are having 5 instances, then it will be showing the average CPU across all those 5 instances. Now, if you want to see individual CPU across all those 5 instances, there is a way. So Azure says apply splitting, and you can say instances. And so currently I'm having only a single instance. That's why it's not showing. But in case if you are having more number of instances, it will show you the average CPU for all those instances. You can see, so there is a high possibility that the average CPU for your across your app service, you are seeing to be around 50-60%. But there is one instance which is having a CPU percentage of 90%. So using this dashboard and using this apply splitting thing, you will be able to see the CPU percentage across those 5 instances. So yeah, this is something that we would wanted to cover on monitoring. There is a lot more to monitoring. There are lots of metrics that are available out of the box. Again, you can leverage all those metrics to see the general health of your application. All right, moving back. We covered CPU and memory percentage. We covered across HTTP requests, and we covered worker process and connection metrics. All right, let's see web jobs. What exactly web jobs are? So we have been habitual of creating some utility jobs on top of our web servers. It's very common for an enterprise application that there are some utility jobs. To name some, there can be a utility job to purge the logs of your web application. The job will be hosted on top of your web server. It will be utilizing the underlying infrastructure, but it will be doing some specific task like purging of logs. Now similar analogy is also possible on top of your app services. So app service Azure exposes web jobs. Using web jobs, you can create these utility jobs, like creating a sitemap or creating a scheduled job for your purging of logs. Again, these web jobs are available in two modes. One is the scheduled mode. Scheduled mode is something like creating a scheduled task on a Windows machine, or creating a cron job on top of your Linux. And there are continuous web jobs also, using which you can continuously monitor something or continuously do some tasks. So both these functionalities are available on top of your web jobs. But again, a word of caution: this is running on top of your web service, which means that it is utilizing the infrastructure of your web service, CPU and RAM. So be cautious while configuring these. There are a number of supported files while configuring these web jobs. You can create a command, a CMD file, you can create a batch file, you can create a shell script, Python script, or a jar. These are the different supported types that are available on top of Azure. And additionally, WebJobs also offers some SDKs that can simplify many programming tasks. Again, common use cases are something around generating your sitemaps, reports, or purging your log files. Let's quickly move ahead and see some assorted traits, cherry on the pie on top of app services. So cloning, the first feature that we wanted to talk about is cloning your app. So when it comes to cloning your app, Azure exposes a feature using which you can clone your app. So what can be a use case for cloning your app? Say supposedly you are having your primary region. The primary region where your application is deployed is East US, and you would want to create a contingency environment in West US, but you would want to create exactly a similar environment, similar settings, what you are having in your primary infrastructure. So one way is that you manually create an app service plan, you manually create an app service, you manually set up all the configuration settings that you are having in your primary center. But the other way is that Azure exposes is cloning your app. Using cloning your app, what it will do, you can decide the resource group as well as the region wherein you would want to clone your app, and it would clone exactly what you are having in your primary region. So that's a very useful feature in case if you are basically creating your contingency environments. One use case, but there may be other use cases also. The other is around CORS configuration. So CORS is all about allowing other domains to basically access your APIs. So generally, what we have been habitual of doing, we are adding all these CORS configurations or different domains on top of our web configuration. So say I'm having a domain abc.com, but I would want to allow pqr.com to access my API. So what generally we would be doing, we would be adding all these domains on top of our web configuration. But Azure exposes all these configurations on top of your Azure portal. You can open Azure portal, go to your app service, and there will be configuration settings that will be specifically mentioning about CORS. Opening that CORS, you'll be able to define all the different domains that you would want to allow. That is another feature, another abstraction that app services has given to us instead of using our web configuration. And the biggest benefit of it is that you can dynamically update your all the domains that you would want to allow. Backup, again a general recommended practice to always backup your system, backup your app service. So Azure exposes ways to backup your app service. You can use this option to backup your app service, and that's a general recommended practice. All right, last but not the least, let's talk about events. So this is again a feature that's in preview, that still not rolled out fully. But what this event exposes, there are some out of the box events that Azure has exposed. Like say you do a deployment, and after that deployment you would want to trigger an email to all of your stakeholders that the deployment has been completed and it's successful. So Azure exposes these type of events wherein you would uh, capture this deployment completed event, and on top of that you can define what you want to do. So these type of functionalities, these type of capabilities are also available on top of Azure, wherein you can use these out of the box events, and you can subscribe to them and do some stuff as required. So yeah, this concludes this chapter. In this chapter, we covered across scaling configurations. How can we scale vertically up and down, and horizontally scale? We covered something around monitoring metrics. How can we monitor? We covered around web jobs, which are mostly around utility, adding utility jobs on top of your app service. And then we covered few assorted traits for app services, which are on your screen. Uh, I think next we have a 5 minutes break. Mihir, you want to take it up?
Yeah, thank you, Rahul. Thanks so much for giving a session on about exploring the app service. It was really helpful. It was really useful. So let's use this time now for the Q&As. I believe there have been few Q&As which have been asked. Uh, there is one particular point where I think somebody was asking about, I think Ashish was asking about the feature flag demos. So do we have Ashish still? Yeah, I don't know. Yeah, okay. So let us go through. So we'll ask Surbi, probably she can give a quick demo about the feature flags.
Yeah.
That would be useful.
Yep. Thanks, Mir. So, yeah. So we'll quickly see how can we configure our feature flags. So during the demo as well, we covered the configuration section of this app services. So this is the place where we can manage our settings or any feature flags required for our application. So for example, let's say I create this new application setting, some feature flag, and I give this value true or any whatever is required for this thing. And I add these settings, I can save it. So as soon as I save this setting, this will be reflected on your application. So generally, without managing the feature flags or modifying these values from the code or from some external configurations, we can manage these feature flags from the Azure portal itself. Now coming to the next interesting question, will it cause some downtime if we change the value? So yes, if we change any value and if we modify any value from this section, there will be a restart in your Azure App Service. So as soon as I add any new application setting or edit any settings from this portal, it will cause a restart on your Azure App Service. But if we really want to achieve a zero downtime for these modifying these feature flags or any app setting changes, we can definitely make use of deployment slots, which we covered. So what we can do, what is the general trend even we have followed with our experiences, we keep these two staging slot and production slot once it is running as a replica of each other. The production slot and the staging slot will be a replica of each other, and all the settings will be present in the this staging slot as well. So I can modify this setting in the staging slot and verify that feature flag after changing the value. And then I can trigger a swap. And in the swap, we have seen that whenever we do the swap, it doesn't cause any downtime for us. And this swap comes with the swap with preview option as well. So if we do a swap with preview, it shows you right now, if you see, this is the phase 2. We have added this setting in the source, but it is not there in the target. And if we do a swap, this setting will be swapped and the new setting will be present into the target after we complete the swap. So this is how we can manage the feature flags from the Azure App Service portal itself and without any need for the whole deployment. I hope this gives an overview how can we manage the feature flags. Please let us know if you have any other question related to feature flags. We'll be happy to share our results in the end of the session as well. Over to you, Mir.
Awesome. Thank you, Surbi. Hope this was helpful, Ashish. Do let us know if there are a few more questions.